We are continuing our study of Chapter 4, goal number 22, and we're looking still at composite functions that contain inverse trig functions in them. So if we look at number 7, we see that the inside contains the inverse and the outside is the standard function. So if the inside contains the inverse, that means that on the inside we will be solving for theta, and when we evaluate the outside of the function, we will be finding the sine of the given angle or looking for the opposite over the hypotenuse. So let's start by following order of operations. Inverse sine of 1/2. Recall that inverse tells us we're looking for an angle. Inverse sine is between negative pi over 2 and positive pi over 2. The 1/2 is positive, so that tells us that we will be in quadrant 1. And in quadrant 1, sine equals 1/2 at pi over 6. So the inverse sine of 1/2 is equivalent to pi over 6. And now we bring down the outside. And we're looking for where is the sine, or what is the sine of pi over 6, or what is the opposite over hypotenuse. And you've learned at this point that the sine of pi over 6 or the sine of 30 degrees is 1/2. If you're not sure about that, remember that you can always look at your unit circle at the ordered pairs. You can see the ordered pair at 30 degrees is root 3 over 2/2. And remember that the y coordinate corresponds to your sine. Or you can draw a right triangle. Because this is positive, 1/2 is positive, I would draw my triangle in quadrant 1. And sine is opposite over hypotenuse. And if we used the Pythagorean theorem or used our ratios, we know that the missing leg is square root of 3. So this shows that we have a 30, 60, 90 right triangle. The angle opposite 1, or the shortest leg, is 30. The angle opposite root 3, or the long leg, is 60 degrees. So our sine would correspond to the sine of 30 is opposite over the hypotenuse. So the sine of pi over 6 is 1/2. Let's look at number 8. Inverse sine of 3/2. So because the inverse is on the interior, we know that the inside is an angle and the outside will ultimately give us opposite over hypotenuse. All right, so 3/2. If I look at my ordered pairs on the unit circle, I see that at 30 degrees we have 1/2. At 45 degrees, root 2 over 2. And at 60 degrees, sine is equal to root 3 over 2. So none of those match this value of 3/2. So perhaps the unit circle doesn't help me to find the inverse in this manner. So I'll also think about the range for inverse sine is negative pi over 2 to pi over 2. And that's what we're looking for. We're looking for an angle. The domain of inverse sine we've learned is negative 1 to 1. And immediately I realize that 3/2, which is 1.5, is not on this interval. So if the value that I am taking the inverse of is not on the interval negative 1 to 1, then this function must be undefined. An alternate way to think about that is about the size of a right triangle. We know that the 3 represents opposite, the 2 represents hypotenuse, and if we try to draw a right triangle with the opposite leg of 3 and a hypotenuse of 2, we know that this would not even form a right triangle because the hypotenuse must be the longest side. Therefore, this function is undefined. Let's take a look at number 9. Evaluate the cosine of the inverse cosine of 0.06. All right, so I know that this is inverse on the interior, so I'm looking for a value for theta. And ultimately, with cosine on the outside, I'm looking for adjacent over hypotenuse. Again, 0.6 is not one of our special angles that we've memorized, so I can draw a right triangle with adjacent over hypotenuse. If the adjacent leg is 0.06, then in this case the hypotenuse would be 1. So to find the interior, I draw a triangle. Adjacent is 0.06. The opposite is the hypotenuse is 1. And now I'm ready to evaluate the outside. And the outside asks me to find the cosine of angle theta. So I will use this right triangle that we just drew to find the cosine of angle theta. And again, we would still use adjacent over hypotenuse, or 0.06. So we've done an example on 7 where we know that the sine is equal to 1/2 at pi over 6. We've done an example where the opposite over hypotenuse is not between -1 and 1, therefore the function is undefined. And we've completed an example where we had to draw a right triangle in order to evaluate the outside function. We had to draw that right triangle because we have not memorized at what angle cosine is equivalent to 0.06. You try number 10 on your own. Please pause the screencast and evaluate the cosine of the inverse cosine of 7. Okay, hopefully you paused and came up with the fact that this is undefined. Again, 7 is not one of our special values that we've memorized on the unit circle, so we would put 7 over 1 and adjacent over hypotenuse. I immediately see that the adjacent side is longer than the hypotenuse, therefore there would be no triangle. The function's undefined. Or you can again look at the domain of inverse cosine. The domain of inverse cosine is -1 to 1, and 7 is not in that interval. Okay, let's take a look at example 11. The inverse is on the inside, so we will be solving for the angle on the inside and then evaluating the tangent of that angle. So ultimately our solution will be opposite over adjacent, or a function value. To evaluate the inside, inverse tan of √3, we know that inverse tangent is restricted to -pi/2 to +pi/2. Tangent is positive in quadrant 1 and equal to the √3 at pi/3. So initially, the interior is equivalent to pi/3. Now we'll bring down the outside and find the tangent of pi/3, which you know is the square root of 3. Let's take a look at number 12. The interior is where the inverse or the arctan is. We know the interior will be equivalent to theta. Therefore, after we find theta, we will evaluate the tangent of that angle by using the opposite over adjacent. So -8/3 is not one of our memorized values on the unit circle. Therefore, we must draw a triangle in order to evaluate the tangent of that angle. So when we draw this triangle, I know that arctan is between -pi/2 and +pi/2. Because 8 is negative, we cannot draw a triangle in quadrant 1 because quadrant 1 tangent is positive. Therefore, we will draw our triangle in quadrant 2. And we now have opposite over adjacent. We could use the Pythagorean theorem to calculate the hypotenuse, but it's not necessary because the inside asks us to find the tangent of angle theta. And tangent evaluates opposite -8 over adjacent +3. So I want you to notice on 7, 9, 11, and 12. So look at 7, 9, 11, and 12. We are taking the inverse sine of a half on the inside, and our final answer is a half. On 9, we're taking the inverse cosine of 0.06, and our solution is 0.06. On 11, we're taking the inverse tangent of root 3, and our solution is root 3. On 12, we're taking the inverse tan of negative 8/3, and our solution is negative 8/3. So you can see on these examples that the sine and its inverse, cosine and its inverse, tangent and its inverse always canceled. Why did those cancel? It all goes back to the domain for inverse sine and cosine, which is -1 to 1. So our new cancellation laws, if the inverse is on the inside of the composite function, if the value we are taking the inverse of is between -1 and 1 for inverse sine and cosine, then the functions will cancel. Because the domain for inverse sine and inverse cosine is -1 to 1, if our function value that we're taking the inverse of is between -1 and 1, the sine and cosine will cancel. If the function value is not between -1 and 1, then the function is undefined. Recall that tangent has a different domain. Recall that inverse tangent has a different domain, and its domain is from -infinity to +infinity. So if the value that we are taking the inverse of is between -infinity and +infinity, the inverse tangent and tangent will cancel. -8/3 is between negative and +infinity, so the tangent and inverse tangent will cancel. So I've summarized our cancellation rules for you, and I would encourage you to make sure that you understand and memorize these to help you. I would jot these down and use them as you are solving your problems. Thank you.